In this video, we want to use completing the square to put a given quadratic function into what is sometimes called vertex or standard form. Let's recall what completing the square refers to. It refers to taking an expression x squared plus some non-zero number times x and adding a number so that the result factors as a square, x plus number or x minus some number squared. And one way to put a given quadratic into this form is to complete the square on the x squared and x term. So let's run through this example and then look at a couple more. As a first step, I like to put parentheses around the x squared and the x term. At the very least, this helps us focus on completing the square on just these two terms. But later on it pays off when we want to do some factoring before we complete the square. But anyway, let's start by putting parentheses around the first two terms. And we want to complete the square on x squared plus 6x. So we take the coefficient on x and let's multiply that by a half to get 3. Square the result and we get 9. So to complete the square, we add 9 inside the parentheses. Okay. And notice that the function here has a value 9 more than the function that we started with. We want to keep the function that we started with, so we have to balance this change that we made, and we can do that by subtracting 9 from the outside. So now this equality is true because 9 minus 9 is 0. The trinomial factors as x plus 3 squared, and the outside simplifies to negative 10. So this is the vertex form for this quadratic equation. Let's look at another example. Let's look at a situation where the coefficient on x squared is different than 1. Let's start the same way by putting parentheses around the x squared and the x term. Whenever we complete the square, we do so on an x squared plus some number times x. The coefficient on x squared has to be 1 in order to complete the square. So my next step is to factor the 3 out of these first two terms. So we're left with x squared plus 2x inside the parentheses. And that's where I want to complete the square. So we take the coefficient on x, multiply it by a half, square the result, and we get 1 in this case. We're going to add 1 inside the parentheses. Okay, and this time, by adding 1 inside the parentheses, which is multiplied by 3, we've actually added 3 to the function value. So we need to subtract 3 to balance that out. And now this simplifies 3 times x plus 1 squared minus 4. One more. Let's complete the square, use completing the square to put this quadratic into vertex 4. So again, I'm going to put parentheses around the x squared and the x term. I need the coefficient on x squared to be 1, so I'm going to factor out a negative 1. Now the coefficient on x squared inside the parentheses is 1, so we can complete the square. Take negative 3 and multiply it by a half. Get negative 3 halves. Square it. We get 9/4. So I'm going to add 9/4 inside the parentheses to complete the square. That 9/4 is being multiplied by a negative 1. So when we added 9/4, we actually subtracted 9/4 from our function value. So the balance is to add 9/4. Final step. Go ahead and write this expression as a perfect square. We squared negative 3 halves to get our 9/4. So this is x minus 3 halves. Quantity squared plus 9/4 on the outside.